Greetings, humans. I am the humble Kiwi and have resided in this bay in New Zealand since I hatched.
I, too, am a Kiwi, because
No, you're not. You're a human, you silly bird brain.
Ha ha, very funny. I'm not a bird, but I am a Kiwi. See, I reside in New Zealand's Whenua Aotearoa, the futuristic eco-city of 2070.
City? I don't see a city.
It's right here. Take a look.
Wow, I know on a bay, but where exactly are we on this sustainable island?
We're on what the humans call the Bay of Plenty, near the Rumataka Mountains on the North Island of New Zealand.
Who was that?
That was Christopher Limeister, the chief transportational engineer who designed many of the infrastructures used in our city. And let me formally introduce myself. I am Adam Akaviti, mayor of the great Whenua Aotearoa.
It seems like quite a large city, so how many people live here?
Approximately 300,000 as of the 2070 census, and is still growing fast.
Additionally, the population is very diverse, as 14% of it is the indigenous Maori people.
Wow, what attracted such a large flock?
The conservation of nature, low taxes, clean energy, and extremely low pollution rates are the main attractions.
Well, why are the pollution rates so low?
Well, Whenua only recycles or composts its waste.
Yes, approximately 95% of the waste is recycled, while the remaining 5% is composted.
I know that sheep outnumber people 9-1, and New Zealand is the leading producer of wool for the world. And the manure, that definitely isn't pheasant.
Well, the manure is managed through a process called anaerobic digestion, or more commonly referred to as manure to methane, or MTM.
During which a biological process takes place, producing a leftover sludge and methane gas.
So the leftover sludge must be used as fertilizer in vertical farms, and the methane must be used as power in fuel cells.
Exactly. Yes. That also ties into the second reason pollution rates are so low. We only use 100% green energy.
Well, your city can't only run on MTM, so what are the other power sources?
There's solar, wind, and mainly geothermal as clean, renewable options.
Geothermal? Doesn't that produce minimal amounts of electricity compared to other alternatives?
Usually yes, but since Whenua is located on the Pacific Rim Fire, geothermal activity is at its peak, allowing for excessive energy to be produced.
Well, why does your city need so much power?
Our city uses so much power because of the new transportation system, which was completely redesigned in 2050.
What did your city do to the infrastructure?
Well, first of all, we identified the problem. Over the past 50 years, we have experienced an extreme rise in traffic congestion, accidents, and long commute times.
Then we learned the specs, which was how to reduce traffic congestion, improve safety, and how to improve the vehicle connectivity.
Next, we brainstormed solutions, which became GPALs, the PTP, and an emphasis on public transit, such as our SCVT. The PTP, or Personal Travel Pilot, has an integrated onboard holographic map that displays a view of the city's multimodal transportation system and also calculates the quickest and most efficient travel route.
That's awesome! Wait, did you say Kiwi Pals?
No, it's GPALs. GPAL stands for Global Positioning Altitude System and is implemented in each pod. Each pod has an onboard computer device which sends and receives data from global satellites.
And what was that STZP thing you mentioned?
The SCVT, or Superconducting Vacuum Train, is a frictionless train that was implemented along with other public transit, such as eco-buses, to reduce the city's carbon footprint and energy consumption.
Then we designed our solutions on computer programs to determine how each mode of transit would work.
So, what was the result?
Well, after several tests and drafts, we concluded that it worked extremely successfully, and we implemented it in phases throughout the city.
I'd imagine there'd be many problems, such as system crashes, power outages, and other weather-related incidents.
Yes, however, they were all solved with the implementation of backup computer systems and auxiliary power sources. Finally, we shared our solutions with the rest of the world.
Now, all transit is working together in unison, and commuters and tourists alike have benefited by reduced traffic congestion, no accidents, and short journey times.
Wow, seems like a lot more goes into engineering and planning than I ever thought about. But what disciplines of engineers were needed to construct the city and the innovative transportation system?
Electrical, computer systems, and transportation engineers designed GPALs, PTP, and SCVT.
Geotechnical engineers designed the geothermal power plants, and civil engineers, like me, designed the road systems and how they flow through the zone plan.
Zone plan? Well, what is the zone plan?
This is a mixed-use zone called Central City. This is a mostly residential zone called the Emerald Coast, and this area on the mountain is Maori Historical Protected Grounds. Then, this area is agricultural and high-tech industrial, and this area is aquacultural.
Interesting. Say, what is this model made out of?
Well, 99% of the model is made of recyclable materials, such as these vertical farms are made of pen tubes.
And these apartment buildings are made from circuit boards.
And these Maori historical homes are made from cardboard boxes, and the trees are made from various spice and lichen.
Exactly.
Wow, this model's really cool.
It gets even better. The model also includes 4 moving parts, as well as various lights.
4?
Yes, they're the SCVT,
Or superconducting vacuum train,
the Total Circle Drawbridge,
which is the only standing drawbridge on the Western Hemisphere,
this wind turbine,
which is an example of our alternative energy sources,
and the Tapari Koi Lighthouse, which stands 340 feet tall.
and is also the transportation hub of our city.
340 feet, but on the model it's just under 7 inches, so the scale must be 1 inch equals 50 feet.
Yes, that's correct.
So, how did the yearly theme of solving tomorrow's transit influence the design process of the model?
Well, 3 of our 4 moving parts have to do with transportation, and we put extreme emphasis on roads, pods, pod platoons, and eco-buses.
Wow, Fenwa Aotearoa is the best place to live in 2070 because of its strong connection to nature, having no pollution, and its innovative transportation system. It inspires me to create my own city exclusively for Kiwis. I shall call it Fenwa Kiwi, land of the Kiwis.
Something.
Thank you.
So do you really think that that transportation system, is the tube one with the high-speed maglev, would work?
Personally, yes, because the technologies are actually already existent today, but what we did, we took them and made them better and combined them.
Okay.
You said that you combined the technologies to make the SCVT better. Can you talk about some of the principles that you were thinking about when you came up with that design?
Well, we wanted a very fast and reliable transportation system. So one of the main things that's holding back speed today is friction. So we had to make it frictionless, for which we used the magnetic levitation and vacuum power.
And what we also did is we made it so then each station, in order to prevent the loss of airflow, what we did is we made it so then the tube is sealed off, and there are different tracks in there in order to prevent the loss of airflow.
Also, all the technologies are today, as I said before, it's essentially an above-ground subway that, and the vacuum power is used today in a pneumatic subway in New York.
So as you think about the transportation system, what are the features of it that allow it to grow with population growth?
Well, the road, we rely also on a road system, which can be easily added onto with construction.
Also, the pods are the same in the SCVT and the roads, so it's easily counterchangeable.
In addition to that, we also made it so then the GPOWs, the network that it runs on, it's expandable so then it can hold up to a capacity of over 5,000 people. 500,000.
How do you enlarge or expand the transportation system without impacting the other positives of your overall city design, environment, green space, etc.?
Well, instead of using a byproduct of oil as the roads today as asphalt, we use because this mountain Ahitapua is a dormant volcano, we grind up pumice rock, ash, water, and lime to make a strong concrete that we use instead of asphalt.
Why did you include a historical protected zone?
Well, the Maori culture is very interesting, and we wanted to keep it with us as we headed into the future. So we used that zone to help tourists and citizens remember their past.
We also wanted to emphasize how nature is very important in New Zealand and how it should be more important in our everyday lives.
You had mentioned that there are several engineers involved in designing the city, and we had some questions about expanding the city. What kind of role will the engineers play in the expansion of the city?
Well, they would like discover what needed to expand and how it would expand.
Like for instance, computer system engineers would keep GPALs and other systems up to date. And
Additionally, since the GPALS it relies on satellites, we would need aerospace engineers. As the city grows in population, we would need essentially more satellites and more communication bases to rely on. So we would need engineers to design these and actually put them to use.
So if you could do this all over again, what's the one thing you would do differently next time? So what did you learn as you built this city?
Well, I learned a lot about engineering, and also I learned not to procrastinate, so that was a big setback.
We had to change something. I wish we had more time because, as Adam said, all three of us huge procrastinators. We would come up short sometimes, so we would have to go into overtime. But eventually, we found a rhythm and we got a finished product, which I think we're all really proud of.
like Adam Nigerbo said, personally, what I learned is that I learned how to come out of my comfort zone because I used to be the kid in the back of the room, was antisocial, didn't really do anything. And this kind of helped me learn how to work with other people and help build my teamwork and social skills. And like they said, if we had to redo anything, I'd probably add more time to the model.
Did you hear a bell?